I'm Anil Kumar sharing with you an important question from my student Ryan. Ryan, thanks a lot for sharing this question. While I provide you with the solution, I'll also explain few concepts which will help you to understand how to solve similar questions where chain rule will be applied. In this particular question, we are given two functions. One is w, which is a function of x. The other one is x, which is a function of t. We need to find dw dt when t equals to 2. So that gives you an idea that dw dt could be written as dw dx times dx dt, right? So that is basic strategy, right? So we can find dw dt as a product of dw dx and dx dt. dw dx we can find by finding derivative of the first function and dx dt as a derivative of the second function. So that's one part to understand. Another thing to understand is that we are actually looking for the value of dw dt as t equals to 2. Now, you know t is 2. Let us say t equals to 2. Now if t equals to 2, then what is x? It is very important to calculate that also before we begin to explore. So if t is 2, then x is equals to, replace t with 2. So we get 2 plus 1 over 2 minus 1, which is 3. So basically, we'll be calculating dw dt for t equals to 2 and x equals to 3. So I hope that helps you kind of give you a background of what we are going to do, right? Now, let us find dw dx, which we can do from the first function, right? Let me change the ink also. So we are given w equals to e to the power of x squared. Dw dx will be e to the power of x squared times derivative of x squared, which is 2x, right? Now, since we want dw dt for x equals to 3, it is kind of useful to write this as dw dx at x equals to 3, right? So we could do that. So we could write x as 3 here. So we get e to the power of 3 squared times 2 times 3. Is it okay? Which is e to the power of 9. And this number is 2 times 3 is 6. It's better to write 6 first. So we get 6e to the power of 9, right? So we got one part. Now let's find the derivative of the second function. The second function is x equals to t plus 1 divided by t minus 1 dx dt equals to, we can apply quotient rule, t minus 1 whole square. Derivative is 1, so we get t minus 1 times, minus. Derivative denominator is also 1, so 1 times t plus 1. So this could be written as t minus t0 minus 1, or let me just extend, t minus 1 minus t minus 1 equals to t minus 1 whole square. That is dx dt, right? Which is minus 2 over t minus 1 whole square dx dt, right? Now, you are interested in finding this value when t is 2. So let us find what is that. Dx dt when t equals to 2 will be minus 2 over, 2 minus 1 whole square, and that is minus 2, correct? So you get the value as minus 2. Now let's find dw dt for t equals to 2 and x equals to 3, right? So at t equals to 2, x is 3. That's the reason. So that should be equals to dw dx at x equals to 3 times dx dt at t equals to 2, right? We have already calculated these values. dw dx at x equals to 3, let me call this as equation 1, is 6 e to the power of 9 times, let me call this as equation 2, dx dt when t equals to 2 is minus 2, right? So when you multiply, you get minus 12 e to the power of 9, correct? So that is your answer. Minus 12 e to the power of 9. Now it is not necessary that you do this, you could do at the end also, okay? So you could have written the expressions which we got here times that expression and then substitute the value of t as 2 and x as 3 and get the answer. So that is also possible, but I prefer to do like this since it simplifies at each step and becomes, easier to handle. I hope that helps. You can also share any question where you need help with. Thank you and all the best.